Hi P5. Okay, let's look at a worksheet. Okay, so basically you have some water that is at 100 degrees Celsius. They are put inside this plastic container, and then the graph, this solid line here, right, shows you how the temperature have dropped. Okay, so you realize that it dropped until here, right? It don't drop anymore, it just stay somewhere along this line. That is because it has reached the room temperature. Okay. The room temperature is the temperature in the surrounding. So they are left it in the table, right? So we just assume he left it in somewhere and in the house. Okay. So let's look at the other line. The other line shows you that the temperature dropped faster. That means the water lose heat faster. Plus it dropped to a lower temperature. So now you have the key clue here is there's a lower room temperature. Okay, let's look at a different possibility. The first one says that you use a more reliable thermometer. Yes, there's a chance that when you use a more reliable thermometer, the results will change. Okay, but it can also be a case where the temperature will drop slower. It can also be a temperature that a case where the temperature drop faster. So there's no guarantee that it will definitely drop faster. In this case, drop faster, right? Okay, there's a chance that you can also drop slower, like I say. So this is not possible. Okay, the second option says that you leave the setup to cool down in the fridge. If you leave it in a fridge, the fridge is a place that has lower temperature than previously because the fridge is cold. So because the surrounding is cold, therefore the water will lose heat faster and therefore it will drop to a lower room temperature. So that's possible. But let's just look at the other options as well. The third option says that use a container made of metal instead of plastic. Now, metal is a good conductor of heat. That means it will take away heat from the boiling water faster. So yes, the temperature will drop faster. However, it will not drop to below the current room temperature. Okay, because it's still at the same location. So what I would have expected is if you use a metal container, the temperature will drop like this. Or you drop faster to a room temperature. But after you reach the room temperature, it won't drop anymore. Okay, so if since they suggest that the room temperature has dropped, that means the surrounding temperature has also decreased lah. That's why 2 is more accurate. Okay. The fourth one asks you to put water at temperature lower than 100 degrees Celsius in a container. Now, if you put this is the most wrong one. If you put an object that's lower at 100 degrees Celsius, the line will not start at 100 degrees Celsius, but you realize the line still start at 100, right? That means the starting temperature is 100 degrees Celsius. So 4 is wrong. So our answer is number 2. Okay, let's look at question 23. Okay, he go and place these 3 objects. You don't know their property. Okay, they can be either transparent, translucent, or opaque. Okay, what happens is this is the result here. The screen is the result here. Now see that the square, right, is partly shaded, and you still can see the star which is behind. And since the square is nearer, that's why it's bigger. So this is nearer to the light source, the square. So this must be the square, and it must be translucent. Okay, I wouldn't say it's transparent because you will see that there's a bit of darkness there. That means the light didn't pass through easily. So I'll say it is translucent. Also A is translucent. Then B casts a shadow, right? Light is blocked, right? So C, the star is C, okay? So it is opaque. Okay, that's why you see a dark shadow there because the light cannot pass through. Okay, so C is opaque. Okay. We don't see B because B is behind C and B has been blocked by C, so you will not know. So this is actually an unknown. So you can only base on 2 of your clues. So A is translucent, right? So translucent is tracing paper. Okay. Cardboard is opaque lah. Clear plastic is transparent so we won't choose them. Then C we know that it's opaque, so you choose cardboard. Cardboard. So your best answer is number 4. Okay. Now, not all P5 students have certain forces. So I'll just briefly explain to you. Okay, first, the gravitational force, no matter where you are, the gravitational force you're experiencing is always pulling you downwards. That's why when you jump, right, you come back down. I don't know if you all know this, but this is Earth. Singapore is on the equator in the middle of the Earth. So actually right now most of us are standing like this on Earth. Okay, but why don't we fall downwards? That's because the gravitational force is pulling you inwards. Also, the gravitational force is pulling us downwards. So it's this two. Okay. Frictional force, friction always opposes motion, meaning if you go forward, the frictional force will go against you, push you back. So since the magnet is moving, they are talking about R. Since the magnet is moving this way, the frictional force must be going the other way. Okay, so it's this two. Okay, then the magnetic force. Then magnetic, even if you haven't learned forces, which is usually a P6 topic, but you should have learned magnet is P3 lah. So the magnet is being attracted over, right? So this is the arrow of the magnet. So that's why it's number 4. Okay, this is again a P3 topic. So let's just randomly write down the poles. By the way, they tell you XY is an iron bar. That means it's just a magnetic material. But it is not a magnet. Therefore, it will not repel. Okay, so no poles because magnet has no, not magnet, so no poles. Only magnets will have poles. Okay, so anyway, just randomly write the poles. North, south, opposite poles attract, right? So this one must be north, south, still. Or like I say, iron bar is a magnetic material, so it will be attracted by the magnet regardless how. Let's look at the possible arrangement. So D and A, it's let's see, D is north, A is south, north, south. So that's possible. F and B is N, so this N, then by right they should repel, right? So this is wrong already. Okay, because like poles should have repel one. A and C is south, so wrong also, because like poles, like I say, should repel. Or as you can see from the above diagram. AD is south north, so south north. Y is a magnetic. Okay, yeah, so that's possible lah, because opposing poles, different poles, they will attract. So this is correct. And then this will attract because it's a magnetic material. This will attract because it's a magnetic material. So number 3 is our best answer. Let's just look at number 4 to be sure. A and C is south and south, so it will repel, so wrong also. That's why it's number 3. Okay, before we do this question, you must always remember only magnets can repel magnets. Magnetic material cannot repel magnet. Magnetic material can only be attracted by magnet. Okay, so let's see. The first one, object P no response, so it must be a non-magnetic material. Okay, example, it's a wood, plastic. They don't get attracted by a magnet. Okay, or it can be a non-magnetic metal like copper, silver, gold. Okay, Q attract on both sides, so it must be a magnetic material. Okay, but it's not a magnet, because it didn't repel. This one repel, so R must definitely be a magnet, because only magnets repel magnets. And this one is a magnetic material. Okay, so they say P, Q, S are not magnets, so that's true because only R is magnet. Q and S are magnetic material. Object R is a magnet. Okay, that's also true. We have deduced that, right? P is a magnetic. Okay, this is wrong. Like you know, P is a non-magnetic material. So also only A and B, which is number 3. Okay, again, these two questions is also talking about friction, so it may be a bit hard for you. Okay, because you have you're not taught in school as well. Okay, usually it's like I say, it's usually a P6 topic, but some school may teach them earlier. So they tell you that the wooden block is moving, and after that it stopped. Okay, so it basically gets slide across, slide, then suddenly at you it stopped moving. Okay, so there's friction. Definitely there's a friction acting on U and S, so this is correct. As long as you are in contact with anything, there will be friction one, even if you are not moving. If there's no friction, you'll be slipping around already. There will weight acting on the wooden block at S. Okay, then they say C there's weight, right? D there's also weight. So all four is correct. So it's A, B, C, D. So for question 28, right, the box didn't slide all the way down. It stopped halfway. Okay. They tell you gravitational force acting is the same. Yes. Oh, this is a trick question. Remember, gravitational force will never change as long as you're on Earth, because the gravitational force we are experiencing every single second comes from Earth. So gravitational force will not change. So it's the same. So let's look at question 29. Question 29 tells you that this substance R, which is only available in C and E, okay, this R absorbs and removes gas X. So you do not know what is gas X. It can be nitrogen, carbon dioxide, oxygen, we don't know. Okay, but they give you another clue. They tell you that the mole only grows on D and F. So what does D and F have that C and E don't have, causing C and A to have no mole growth? It is this substance R. So substance R must have definitely done something to the mole. Okay, so substance R have what? Okay, it absorbs away certain gas, right? So what does it absorb away? It absorb away oxygen. Because in order for the spores of mole to grow, you must have oxygen. Okay, so they ask you, in D and F, right? Why is there in D and F, right? Among D and F, they both have mole, and which one has more? Okay, so in order for you to answer that, you must first know that in order for the mole to grow, you need air, which is oxygen, and moisture, as well as warmth. Okay, so it must be a warm place. Okay, moisture, that means the amount of water in the amount of water vapor in the surrounding lah. So because D and F has warm, right? So that's why box F will go first. Okay, and because of that, there will be more moles growing. Okay, then you need to explain, right? So let's write this down. Okay, only it's warm to grow. So I already tell you what is a gas X, right? So it's your oxygen. Okay, then the next one, they ask you why you say it's oxygen. So this one I also explained just now, but let's just write out again. Okay, let's look at this one. So let me just explain to you what I'm writing. Okay, so as we know, just now I already mentioned the three things mole need in order to grow is warmth, moisture, and air. Air meaning oxygen. So substance R is taking away some kind of air, right? That's why it cannot grow, right? So it must be taking away the oxygen, because oxygen is needed in order for mole to grow. Okay, so based on the experiment Andrew has conducted, identify one way he could store his leather bag. Okay, so there's a few ways lah. Okay, first is you know that you can put something that absorbs away the oxygen. Okay, so first one is place substance. Okay, so no oxygen, the mole cannot grow on the leather bag lah. Okay, the reason why it grows on leather bag is because leather is an organic natural material, so mole feeds on a natural material. Okay, but this is not the best answer, because if you place substance R near, it's still actually impossible to remove oxygen, because oxygen is all around us. Okay, unless you keep the bag in a place tightly sealed, no air, no nothing. Okay, so the other answer will be the better answer. So since you cannot remove uh, uh, oxygen, right, because oxygen is all around us, the other alternative based on what we have seen from question A is that you can place it in a cooler place. Okay, I mean it will still grow, but it will take a long time to grow because there's no warmth. So put it in a cooler place. So Farah is doing an exercise, star jump. So he measured his heart rate after every 20 jumps. Okay, question A tells you that one of the reading is wrong. So when you exercise, the heart rate should increase, what? But this one stay as 40. So this is the wrong one. Okay, but right should increase when you exercise, but it drops to 40. So this is the wrong one. So what's the relationship between the number of star jumps and heart rate? So as you can see when he jump more time, the heart rate will shoot up. So let's write this down. Okay, so just copy what they write . So when she do more star jumps, the heart rate will be faster. It's a circulatory system topic. You cannot say that when her heart rate increase, the star jumps increase. No, because it is the number of star jumps that cause her heart rate to increase, not the heart rate increase. That's why she do more star jump. So you must talk about when the star jumps increase first. You must talk about this first before you can talk about heart rate. Also, whenever you repeat experiment, it is to increase reliability. I've told you a lot of times. So when you carry out experiment, you can have a perfect setup. Everything is the same except for while you're testing. But when you write down your data, right? Okay, maybe you write wrongly. So that's all these are human error, which is inevitable. There's a chance that you do it because we are human and then we make mistake. So that's the reason why you have to repeat your experiment 3 times. Okay, so let's write this down. So when you increase the reliability, meaning there's less chance of having a mistake. So if you look at her after she do 3 times sorry, you realize she can easily spot her mistake, why not? Or if she only do, let's say she only do the second attempt 1 time, then 40 is a mistake, she also won't realize. Okay, because now there's 2 other attempts for her to compare with. That's why we must always repeat our experiment a few times to increase the reliability. But that's not the only way. Other than repeating an experiment, the other way is to have a bigger sample. Bigger sample is, let's say for example, I want to find out if earthworm is attracted to light. Also, instead of using only 1 earthworm, I can have 10 earthworms. So that will be a more reliable answer setup. Okay. So when you have more sample size, so 2 ways. One is repeat experiment a few times. The second one is to have a bigger sample size. That means more things participating in it. Okay, let's go 31. So they're basically trapped in a lift Okay, can you realize that this one is starting to drop? Your B is starting to drop, whereas A stays the same. So gas A anyway, gas A is a lot. So you should know that in the atmosphere, in the air around us, the most common air is nitrogen. Anyway, nitrogen is not needed by our body, so the nitrogen level won't drop. So this nitrogen, make sure spelling is correct. So anyway, gas B is oxygen. That's why it's dropping because they are breathing so they are using out oxygen. So after 20 minutes, they are still stuck in the lift. The gas B, which is oxygen, starts to decrease quickly. So why is it that it decreases more quickly after 20 minutes? So after 20 minutes, what do? They start to knock. That means they starts to use more energy. That means they need more oxygen. So anyway, gas B is oxygen. So that's why after 20 minutes, her oxygen will decrease faster because it's being used up. Okay. So like I mentioned, I'll just repeat. So because they are moving around, trying to open the door, keep the door, so they're using strength, using energy. So when you use energy, right, you need more oxygen so that they can produce more oxygen. They can use oxygen to turn them into energy. Anyway, I mean you don't learn in P5, but during respiration you basically combine digested food and oxygen to generate energy lah. That's why you need more oxygen. So I've told you a lot of times in an experiment everything must be the same except for what you're testing. So she's trying to find out if the number of leaves affects the amount of water taken. So the number of leaves is what you're testing, right? So since this is what you're testing, then it must be the only difference in the experiment. Okay? So the number of leaves must be different, correct? But the amount of water is different and the location is different. So first, provide, maybe I write. Okay, give them both the same amount of water, sorry. Okay, that will be fair. Then the other one is about the location, right? So place in a place that they can survive lah. So there must be light. So don't put it in a science room. Put it in eco garden where you can get more light. So place both set up in the eco garden. So same location, same amount of water already. So it's a fair test. Okay, let's say question B. Joanna conducted an experiment. She made all the changes already, so now it's a fair test already. Okay, so they ask you if it's a fair test, would there be more water taken by the plants with more leaf or less leaf? So basically, first you need to understand when there's more leaf. Sorry, let me write this down. When you have more leaf, there will be more photosynthesis. Photosynthesis requires carbon dioxide, light and water, right? So when you photosynthesis more, you need more water also. When you need more water, the roots will take up more water. Roots take more water. Okay, so let's write this down. Okay, so as we know, the water left in X should be lesser because the plants have taken in more water already. So Joanne should observe which setup have a greater decrease in water. Okay, so the one with a greater decrease in water will suggest that the plants take up more water. Okay, that's all for today. Thank you.